Mars, the fourth planet from the Sun, is an intriguing neighbor whose physical conditions present a stark, fascinating contrast to those found on Earth. When examining the basic physical qualities of this rusty terrestrial sphere, one of the most fundamental characteristics to look at is its overall density. The bulk density of Mars is approximately 3.93 grams per cubic centimeter, which makes it noticeably less dense than Earth. This lower density stems largely from a slightly lighter interior composition, as well as a smaller overall size, resulting in a surface gravity that is roughly 38% of Earth's. Beyond the planet's solid structure, the atmospheric air density at the Martian surface is remarkably low. On average, the air density is only about 0.02 kilograms per cubic meter, representing roughly 1 to 2% of the atmospheric density humans experience at sea level on Earth. This sparse air density is directly tied to the nature of the air itself on Mars. The air is dominated almost entirely by carbon dioxide, which accounts for roughly 95% of the total atmospheric composition. Molecular nitrogen makes up about 2.6 to 2.8%, followed by argon at around 1.9%, with only microscopic trace amounts of oxygen, water vapor, and carbon monoxide scattered throughout. Because there is virtually no free oxygen, human survival without specialized pressurized breathing apparatuses is entirely impossible. Furthermore, fine particles of iron oxide dust are constantly suspended within this thin envelope of air, scattering sunlight and imparting a distinct butterscotch or reddish hue to the Martian daytime sky. Because the atmosphere is so thin and wispy, the resulting atmospheric pressure on the surface of Mars is extremely low. The average surface pressure hovers around 6 to 7 millibars, or about 610 pascals. To put this into perspective, that is less than 1% of Earth's standard sea level pressure. Experiencing the atmospheric pressure of Mars on Earth would require traveling to an altitude roughly 35 kilometers above the ground, high into the stratosphere. This drastically low pressure means liquid water cannot remain stable on the Martian surface today. Exposed liquid water rapidly boils away or freezes depending on the immediate surroundings. Interestingly, Martian pressure fluctuates seasonally by up to 25 to 30%. During the harsh polar winters, large amounts of atmospheric carbon dioxide freeze directly out of the air onto the polar caps as dry ice, causing a measurable global drop in total atmospheric pressure. The combination of a thin atmosphere and a greater distance from the Sun leads to extremely cold and variable temperatures on Mars. The overall average surface temperature sits around -80 degrees Fahrenheit, or roughly -60 degrees Celsius. However, because the thin blanket of air offers very little thermal insulation to hold on to daytime heat, the daily temperature swings can be dramatic. On a warm summer afternoon near the Martian equator, ground temperatures can rise to a comfortable 70 degrees Fahrenheit, or about 20 degrees Celsius. Yet, as soon as night falls in that exact same location, heat radiates instantly back out into space, causing the temperature to plummet to -100 degrees Fahrenheit or lower. During winter near the polar regions, conditions turn even more brutal, reaching staggering lows around -195 degrees Fahrenheit, cold enough to freeze the very air itself into solid ground frost. Thanks for watching and subscribe for more.